how to convert hexadecimal numbers into denary, and then back again, denary numbers back into hexadecimal. So the last time, in the last video, I talked to you about binary numbers. All right, and when we did binary numbers, we got to hold this sort of grid in mind, this 8-bit binary grid in mind. So if I just real quick just took the number, or just took the number 100 to make this really simple, and took the number 100 to make this simple. All right, I would do, oh god, right, there's no, I wouldn't need any 128. I would need a 64 and a 32. That would give me, is that right? Is that giving me 96? Which means I need another 4. So I don't need any 16s or 8. I do need a 4, don't need a 2, and I don't need a 1, okay? And that binary number would give me 100, okay? And if I just add those up together, just to double check them, it gives me a sum of 100. So I can see that that's right, okay? So that's the binary number system. So therefore, in every digit, when we move to the next section, we multiply by 2, okay? So we would call the binary system a base 2 system, okay? Because in every, as we move between the digits, we multiply by 2 to get us to the next bit. Okay. Well, okay. Hexadecimal is similar, all right? In hexadecimal, it is a base 16 number system. So therefore, in every unit, we multiply by 16 to get to the next unit, to the next digit. So there is a chart in hexadecimal, and that chart runs from 1 through to, and have I left myself enough numbers here, 10, 11, 12, 13, 14, I haven't. That chart runs from 1 to 15, okay? You just said 16 though. Yes, I did say 16, but the chart, the conversion chart we need runs from 1 to 15, and this is the way we do it. If we think about a nibble, okay, and if we the total number, if we're going to add, if we take 1 in every unit on our binary system there, if we take a 1 in every unit, and I'm wondering if anyone remembers this from last time, that these add up. That means that all of these channels are on. 8 plus 4 plus 2 plus 1 is on, and that gives us a sum of 15. Okay, so that is a nibble. All right, that is a nibble. So if we think of this in a nibble as 1 unit in hexadecimal, adding up to a nibble, that sort of makes a little bit of sense. And then when we go to the next unit, then of course it goes to 16. All right, so the first unit will have a total of 15, and therefore we need 1 character to represent that. So if I change these A, B, C, D, then when you're sat in your exam, in your computer science exam, you can now think, oh right, that's what he said. It was a nibble, wasn't it? Okay, so if it adds up to a nibble, then I don't need to see that chart anymore. I can write one myself, because all I need is numbers through 1 to 15, and then a corresponding, once it gets to 9, once it gets to 2 digits, then I need to represent the 10 as an A, the 11 as a B, 12 as a C, the 13 as a D, and so on up to 15 as an F. Okay, well, yeah, that sounds a little bit confusing, but believe me, it's actually a really simple calculation here. So if we were to represent a hexadecimal number, when you see them represented, you see them represented as a, should I take one here as a 6, and then what you'd see is the number 16 after it. Okay, and you see the number 16 after it. So therefore, there's a 16, and you see that in subscript. Okay, like so on. Okay, you could also see the number. Oh gosh, we take 6A, but of course that could be that could be a hexadecimal number. I'm just going to take this 16. And I'm going to subscript that. Okay, as I said, hexadecimal numbers have a base of 16, so you'll often see them in an exam written like this, and it's a really good idea to when you're in the exam to work in exactly the same way, to write them with a subscript of 16, so it's really, really clear that you are working in, you are calling hexadecimals. So if you had an hexadecimal 6 and 6, you'd put a 16 as a subscript afterwards, so they didn't think that you were working in a denary number of 66. Denary is represented with a base 10. Denary is represented with a base 10, and binary would be represented as a base 2 as such, and that would show that you're not working in the binary number. The denary number 1101. You're actually using a binary number 1101, which of course is equal to denary 30. Okay, so let's have a think about solving some of these. Let's have a think about converting these from hexadecimal to denary. And there's a lovely way of checking this as well, the double checking it using binary. So keeping it simple, first of all, if we take the letter A, well, we know that that's equal to, if we look at our conversion chart up above, we know that that's equal to 10. All right, well, okay, that's easy enough. 6. Well, there's no surprises here, and it's in our first. So it's in our first unit because we're doing A6. It's in our first digit, and we would know that that's equal to, no surprises, 6. All right, but as the A is in the second, just like in binary, if we think about our binary system for a second, when we move to the second digit in binary, we have to multiply by 2. And for the third, multiply by 2 again, and by 2 again, and by 2. Well, in hexadecimal, we would work in the first unit, and in the second unit we'd multiply by 16 in the third lot. So therefore, if we have a 10 hexadecimal number, that would be 0 lots in the first digit, and the second one would be 1 multiplied by 16. So 10 in hexadecimal would be 16. So A equals to 10. So it's not 10 though, is it? It's 10 multiplied by 16. And if this one's in the first unit, it's 16, 6 multiplied by 1. Okay. No surprises here. All right. So that in that case, 10 multiplied by 16 is simply 160. And 6 multiplied by 1 is, of course, 6. And then all we need to do is simply add those together. Try that again. 6 is 166. All right. Well, that's nice and easy there, isn't it? And that's nice and easy, and that's easy to solve. Now, you can double check this as well using the binary system, which is really, really useful. And as I said before, we're thinking of these as nibbles. All right. So if I just pinch this from here, so pinch it from the binary system, if you like, and I'm gonna split this up a little bit. All right, split that up a little bit. So, but instead of using 1, 2, 4, 8, and then the second 16, 32, 64, 128, I'm just going to change that. So I've actually got 2 lots of nibbles. Okay, 1, 2, 4, and 8, then 1, 2, 4, and 8. I'm going to take our A and leave that here. We know that A is equal to 10. Right, and then if I look at the system here, I can go, right, okay, if I convert 10 to a nibble, I'm going to say, well, there's 1 lot of 8, there's no lots of 4, there's 1 lot of 2, because 8 plus 2 is 10, and there's nothing left over. All right, that's straightforward, that's easy enough. And the other one was 6, so, well, I'm just not going to mess about with that because that's a 6, 1 lot of 4, 1 lot of 2, and of course the other one, so 0 and 0. Yeah, 8, 10, and 2. So then if we take if we pinch this, then so we've got our 2 separate nibbles, and all I'm going to do is I'm going to copy and paste that below there just to demonstrate this. Clearly you do this on paper if you were doing this in the exam. and I'm going to put these back together again. So I've got my two nibbles back together again. I'm simply going to say, okay, 1, 2, 4, 8, 16, 32, 64, 128. Well, what does that add up to? Well, I've got one lot of 128. I've got one lot of 32. I've got one lot of 4, and I got one lot of 2. And that, as you can see, adds up to a sum of 166. So if I was going to convert, hexadecimal into binary, then it's simply convert them into two separate nibbles. Put the two separate nibbles, put the nibbles together, change the second part of the nibble, so it is 1, 2, 4, 8. So then it's 16, 32, 64, 128, as I have done here, and then just simply double check it by adding them adding them together to finish off the binary to Denary conversion to create a Denary number. Okay, nice and simple. If we put them all together, and this shows here, this also gives you a way of double checking it for your exam as well. So therefore, not making any silly mistakes. Do it this way. Do it this way. That's going to definitely get me a point. But I might have this wrong. I can double check it then to do it that way. Okay? Hopefully that makes sense to you. Nice and straightforward. Nice and straightforward. You're only going to really need to deal in 2 units for GCSE, so no need to panic about anything further than that. Okay, well done, folks. Thank you very much. So what about changing them back again then? What about if you were given a Denary number and asked to convert that into hexadecimal? So let's just take one at random. So if I take a Denary number, I'm going to pinch this 13 from over here just for the fun of it here, but I'm not going to work with 13. Let's work with something a bit more challenging, is it? Let's work with just say 150 for the fun of it. Okay, so if I'm going to work with the Denary number 150, and I want to convert that to hexadecimal. All right, so if I'm going to, so there we go. How am I going to do that? Well, there's a few ways I could mess about with my 16s and get a bit confused, possibly, just to convert this through. But the easy way to do this is to say, okay, then 150. First thing is let's convert that to binary. Once I've converted it to binary, I'm going to separate the nibbles, and then once I've separated the nibbles, I can break it down to single units, and then that's going to give me the hexadecimal. Okay, so 150. So test my maths here. So 150. I'm going to use 128. 9, 30, 40, 50 leaves me 22. So there's not 64, there's not a 32, there is a 16. 16 gives me 6, is it left? So if I put 4 there, 1 there, and a 0 there, and we'll just double check that, is it? 128, 16, 4, 2, and it is the sum of 150, okay? So therefore, that gives me my binary number. Fantastic, all right? So I've converted 150 into binary. Now I'm going to take it to my next level down here. I'm going to split this up into 2 separate nibbles. It's 1, 2, 4, 8, and I put a 1 here. 1, 2, 4, 8, 1, 2, 4, 8. This gives me the binary here of 6. All right, and that gives me the binary number. To convert my nibble. This nibble converted to Denary is 6. This nibble converted to 9 is this nibble converted to Denary is 9. So that means I've got the number 9, 6. All right. Well, I don't need to convert those any further. So I know that's 9, 6. Oops, spell that properly. Now, I would demonstrate that as 9, 6. I would put a 16 after it because I just want to make sure that it's really clear to the examiner that I know what I'm talking about, right? And I got to make sure that I put that in subscript underneath, so it drops beneath the line 96. So it's the number 96. Can I double check that? Yes, I can I? So I can say 9, and then I can multiply that by 16, which gives me, should we say, equals 9 multiplied by 16, right? Which gives me 144. 6, as we know, and of course, it's going to be 6 multiplied by 1. Well, all right, that's easy enough. That's going to give me 6, and then I'm going to add those two numbers together, 140. So it simply is 144 plus 6, as we all know, is 150. And there it is. I've double checked it as well, so I make sure I'm going to get all my points when it comes to exam day. Okay, straightforward enough. Hope that helps, ladies and gents.